Thank you for joining us. And then also for those probably on the stream too. So today we have Bob Paulin, our very own Bob, who's here. So thank you. And he'll be talking about polyglot pipelines with Apache Nifi. Let me see. Let me advance this. Okay. Before we start, if you are interested in entering the JetBrains raffles, and if you have not won anything in the past 9 months or so, you are eligible to enter into this drawing. We'll have 2 licenses that you can pick, one of the JetBrains product if you win. So, okay. All right, so I'll leave this on for a little bit if you want to do that. You just need to give your name and your email address, and then we'll do a spin, like a wheel of names at the end, and pick 2 names. So, okay. Okay, good. Okay, just some housekeeping. We have our Chicago Tech Slack. It's still up. I think there are over 11,000 subscribers now. This is like pretty cool. There are people also outside the area too, where you can communicate. It's like a forum. You can communicate with one another. It's an online social platform. So please consider joining it if you like. And then there are also like job boards and events and things like that to specific like tech channels too. And then there's also Java Off Heap, where you can get current Java news, and of which Bob is a member of the Off Heap with Freddie, right? The 2 of you.
Michael Manella.
And Michael, yes.
Yeah. And Josh Juno.
I got it confused because you also have another too, right? Yeah. And what is that one?
That one's called Pubhouse.
Oh,
so
Pubhouse.
That one's tutorials.
Oh, yeah, that's right. Yeah, there are 2. So yeah, so please sign up or follow them. Yeah, so. And also join us on meetup.com if you haven't already done so. And we still call it the Chirp because it's the Twitter, although it's now called X. We have our handle at CJUG. If you haven't followed us yet, please do. And then we also have a chat channel on Discord. And that's, if you can join that, the top link. And then the bottom link is basically every time we have a meetup, we create a room. So then if you have more questions for the speaker or, on that subject matter being presented, you're welcome to discuss too. And today is about Apache Nifi. So join that room if you like. And some community info. So we are a community partner of JetBrains. That's why every month we get 2 free licenses from JetBrains. And then also we are community partner with this company called devitjobs.us. And they are IT recruiting site that you can join. Okay, so this one is exciting. We have Venkat, the legendary Venkat Subramaniam, running his first conference in Denver on September 30th to October 3rd. That's the link to the event, Dev2Next. And also, too, he's giving a special discount for JUG members too, although I thought I have it somehow. I guess well, anyway, if you're interested in going, we'll be in Denver. So he's giving discount to all JUG members too. So let me know if you're going and would like the coupon code. I think that right now they're still having that early bird kind of ticket sale. I think only until this weekend. So just keep that in mind. Upcoming events. We'll have Venkat Subramaniam, in fact, coming to Chicago for Go to Chicago, which is on 21st and 23rd of October. And he will be doing a presentation on the 21st exclusively for CJUG members and other people in Chicago too. Then November 19th, we'll have from Neo4j, our newest gold sponsor, Neo4j. They will be sending Jennifer Reef, who's a senior developer advocate, she'll be coming here, and her topic will be talking about generative AI, and then with Neo4j. And then there are other confirmed speakers. Alina Yurenko, if you are familiar with her, she's the advocate at Oracle for GraalVM. She's based currently in Switzerland, although she's originally from Ukraine. I think some of our members are from Ukraine here. So very nice lady too. I just recently saw her. And so she's happy, she wants to do a talk for us, but we need to figure out a time to have her. And that will be a virtual conference for now with her virtual presentation. So stay tuned. And then we also have Josie Pamalt from Oracle too. He's also a developer advocate, an experienced, very experienced one on Java and JVM. And then we're still trying to see if there are enough interest we can do an on meetup, kind of an unconference style type of meetup too. So let me know if you're interested. And then if you are interested in speaking at CJUG, please submit your proposals to present@cjug.org. That's that. And for job seekers and recruiters, please, you can join we have a CJUG group on LinkedIn. That's the link to join it. And then also too, at this point, I'm not sure if anybody would like to share, your story, so to speak, if you are looking for a job or if you are looking for a partner on your projects or looking for somebody to just like work together, or if you're looking for people to join your project or is hiring, and you're welcome to kind of stand up and speak for a couple minutes if you like it. Does anybody have anything you want to share at this point? Yeah, and then if you don't, that's okay too. And then we'll have time to socialize again afterwards too. So, okay. Oops, that one, we go here. And now we go to our sponsorship section. Neo4j is our newest gold sponsor. So very happy with them. And they actually are running a monthly raffle too. So if you're interested, I believe this month that it will be, this is actually for last month, but I haven't got the confirmation, but for sure, they will be running a monthly raffle of some kind. So it should be good too if they are giving out drone. And I believe this month will be something, not worse than that. And so if you're interested, you can scan that, or let's see if there's any update to it, I'll send an email, or not email, send a message out on the Discord channel to let you know a new link. Otherwise too, this is how you can enter the raffle. You scan that and then fill in that form for that. And then we have Friends of CJUG. These are the worldwide Java community, and Atlanta JUG, the Boston, New England Java user, ACM chapter, the Garden State JUG from New Jersey, Kansas City JUG, Missouri, New York JavaSig, the oldest Java users group in the US from New York City, and the Pittsburgh JUG from Pennsylvania. So these are our special friends. And you can go to them. They are still running some meetups that are virtual too. So check them out. And now it's our speaker for today and our CJUG's very own Bob Paulin. Yeah. Okay, just a quick introduction. Bob is currently a principal engineer at Datavolo. And he has been you were an independent software consultant for over 12 years too, prior to this. And you have very deep software development and analytical background. I see all of the list of work you do. And then you're also the VP of fundraising at the Apache Software Foundation. And you're involved with multiple Apache projects, such as PMC and also committer too for Tika, Felix, and Camel. And Bob has been a CJUG board member and a leader since 2013, and you were a past president and sponsorship director, CFO. You run through all the gamut. You've done it. So and now he's doing the VP of fundraising at ASF, but you're still involved with the board. So thank you. And you're also a proud dad and coach to 4 beautiful children. So, and with that, I want to hand the stage over to Bob. So thank you. Yeah. Okay.
Thank you. All right. Thank you, Mary.
Thank you. Yeah. And do you use this, or you
I'm going to use the lapel. Let me turn it back on. If you want to hold on to that, if there's questions, let me unmute.
Sure. Oh, and
see if that. Oh, there we go.
Good. Yeah. Okay.
Yeah, very good.
I totally forgot. How can I not thank Microsoft too for sponsoring the space? Yeah, I always forget something. So sorry. I was doing it in a hurry when I was flying back from Cincinnati. And it's like, I knew I forgot something. So thank you again to Microsoft, although I think David is not feeling well, so he's not here at the moment. But if you see him, tell him thank you, David Giard. Yeah, he's wearing the mask right now. Unfortunately, he's not feeling too good. So yeah, okay.
All right, let me get my workspace up and then we'll get rolling. Yeah.
Okay, you don't need this, right?
Yeah, no, you can, if you want to just hold on to that or turn it off.
I'll turn it off.
We're all good.
Okay. Okay. All right. Thank you.
I can still hear that mic echoing. There we go. All right. Well, welcome. So Mary gave a great introduction to me, so I don't really have much more to talk about as far as myself. But we're going to be talking about Apache Nifi and Polyglot pipelines. This is a little loud. Let me turn this down a smidge. Is that a little better?
A couple pictures.
Okay. Yeah, I tend to be loud. I don't need a mic, but for recording, I'll be wearing it. So for those of you that heard Mary's introduction, probably the biggest change for me recently is I'm employed again instead of being independent. So I'm working at a company called Databolo. Databolo has a number of Apache Nifi committers, the original committers for the project. So a lot of the work they do is in Apache Nifi. That's still really loud. Let me turn it down a little more. How's that? Yeah. Okay. That doesn't have an echo. So a large portion of the Nifi community is there. It's actually a project that I'm not a committer on the PMC for, but working on that. So we're going to talk a little bit today about kind of an intersection of AI, of Python, of Java, because we're at a really interesting point right now in software development where really interactions between languages and trying to help pick the right tool for the job to get things done for companies is becoming a major thing. And being a Java engineer, I'm always looking for the best tool, and often I can find it in the JVM. But today we're going to talk about finding things outside the JVM as well as inside. So let's move on. So who here has heard of or used Apache Nifi in the past? Okay, we got a couple hands. And that's just fine. So I'm planning on doing a little demo just to kind of get you guys up to speed on how this project works. So this is an Apache top-level project for data, for processing unstructured and structured data. Apache Nifi, again, being an Apache project, all the code that I'm going to be working with right now today is all open source. So you guys can look at it, you can download the bits, you can play around with it. I have a GitHub repo with my demo in it, so we'll all be able to take that home with us and work on it. So what Apache Nifi can do is it can take data from various sources in your company and move it to other places. It can process it. It can run transformations on it, take unstructured text and make it structured. So if you're trying to save it to a database, those are some of the use cases that you can do. But it doesn't make sense just to talk about it, so I might as well just show some of it off. So I have an instance of Apache Nifi running locally. And this is the new 2.0 milestone 4. So this is the most recent milestone from the Apache project. So it's still pre-release right now, but it has a number of new cool features that I'm going to be talking through. So the very first thing you see in Nifi is there's a UI. So a lot of our data ingestion projects that I've worked on in the past, it's all code, right? So Camel is almost all code. You've got to buy a product or something to use a UI with Camel. Apache Nifi comes with a UI already built in. So you start it, it runs a Java process. You can open it in a browser, and that's where it gets configured. So the very first thing, I've got a couple of little boxes on here, which we're going to pretend don't exist right now. And I'm going to drag down what's called a process group. So whenever I'm building something in Nifi, I kind of want to have a space for it to keep things organized. So if I bring in a process group, that's going to give it its own little workspace for me to create something in. So if I do my workspace and hit add, I'm going to get a brand new box. And if I click on that box, I get a blank canvas. So now I can start working on whatever I want to do right now in Nifi. So at this point, you got to kind of know what's of interest. So how many have either search engines or have data within your company that people need to search for? A lot of hands for that. That's a very common use case and a very common thing that people do with Nifi. So what we're going to do to start things off is we're going to just talk about indexing all the public salaries in Chicago into an open search search engine. So OpenSearch, those of you that have kind of been watching, OpenSearch is a fork of Elastic to keep the Apache software license attached. Since Elastic changed the license to BSL, there were a number of companies that kind of joined together and forked to create OpenSearch. There's a number of compatibilities still between those projects because of the shared source that they still have. We'll see how long that lasts. But for right now, OpenSearch and Elastic have a number of compatible APIs. So what we're going to do is we're going to take data from the data portal in Chicago, and we're going to put it into Elastic using Apache Nifi. So the very first thing I need to do is get data into Nifi. So to bring data into Nifi, what I need to do is I need to create a processor. Am I still hearing an echo? I'm just trying to figure out if there's something else I need to mute. Oh, here we go. Let's mute that one too. Is that a little better? Ooh, I think that was it. All right. So what I'm going to do is I'm going to create a processor that works over HTTP. So I'm going to type HTTP in the search. I'm going to pick invoke HTTP, and that puts another box down on my canvas. Now, if I go into the box, I can see a number of things I can configure. This is a processor. This does actual work in Apache Nifi. So you can see I can control the HTTP verb. There's a spot for me to put the URL. So now I got to figure out, well, okay, where do I want to pull my data from? So Chicago has this great data portal that already has all of the current employees' salaries, their positions, and it is available via API. So if I go down to the API, I have different formats that I can pick. Let's say I want it in CSV, because everybody knows JSON, right? So let's make it interesting. And then there's a URL that I can use here in order to pull that off of the data portal. So we'll take that and we'll put that into the HTTP URL here. Click OK. So now this processor is configured to make a GET call out to this URL and pull that data in. So the next piece of this is you can see there's still this little warning sign here on the processor. It's because it's not completely configured. There's something going into it, but we don't have things coming out. These are relationships that are defined with the processors, which is, hey, once I get the data, where do I send it? So if I click back in here, there's a number of relationships defined, and this is the outgoing data. So if it fails, yeah, maybe I don't care. So I'm just going to terminate it. Retry, let's not worry about that. I don't care about the original. It's a GET request. There's no body. So I'm not going to worry about the original data input, but I can set that if I want. The response, I'm interested in that. The retry, if I wanted to retry if something failed, I can use that relationship for the retry. We're not going to worry about that right now. We're going to keep it simple. So now if I go back, I only got one problem, which is, hey, I didn't told it where that response relationship is going to go. So let's find somewhere for it to go. So Nifi has an Elastic, a put Elastic record processor that I can use. And what I can do with this is I can connect, I can click on the little arrow here, drag it down, and connect those two things together and say, all right, if I get a response back, that's going to go to Elastic. I'm going to keep adjusting this. This is still too loud for me. Turn it down all the way. Maybe a little more. How's that? Yeah, maybe that's better. All right. So it seems like when I'm around this, it's worse. So it's like I'm trying to like ease out. Is one of these on maybe? Like I feel like one of these may be on somehow. All right. Okay. So my Elastic record processor, now it's showing it needs some configuration. So what I'm going to do here is we'll go into we'll start with our relationships because this is the end of the road. I'm indexing something into search. So if there's an error, we're going to terminate it. If there's a failure, we'll terminate the original, we'll terminate retry. If it's successful, we'll terminate it. We'll go into our properties. The operation that we're going to do is index. We're going to index the data. We're going to put it in an index that I've already created. I have it running in a Docker Compose file with a port 9200 exposed, which is your typical open source, your OpenSearch port. And then we'll do CSV index is the name of the index. And then we have a couple of these bolded fields that aren't filled in. Now, within Nifi, I can define something called a service if the thing I'm configuring might be used across things, Like let's say my Elasticsearch, I can do a lot of things with Elasticsearch, right? I can index, I can query with Elasticsearch, I can delete things with Elasticsearch, and all of these are going to use the same configuration. I can use a service within NiFi to say, here is a common configuration that all of these operations are going to use, whether it's an index, a search, or a delete. I'm going to configure it once because it's probably the same host, right? It's probably has a lot of the same configuration. Let's just use the same service across different processors. So I'm going to configure that here. So I'll add that one. The other thing it's going to need is a record reader. Because one thing I'm going to do with all of this CSV data is I'm going to parse it into individual rows, because the CSV has got rows, thousands of rows of data. I'm going to parse it so that when I put it in the index, every single column is going to be its own field in OpenSearch. So since I know it's CSV, we're going to use the CSV reader, and we're going to throw that service down. The last thing I'm going to do is a record result writer. And this is what it would look like coming out of this processor. So I've already set, okay, it's coming in as CSV, but let's say, you know, the thing I might do with it afterwards is I'm going to send it as I want to look at it in JSON. Maybe I want to log in JSON. Maybe I want to send it to a downstream system in JSON format. So my record writer is going to write that same CSV record in a different format, which is I can choose here as JSON. So if I choose the JSON record set writer and add that, now when it comes out of this service, it's going to be in JSON. So I can change formats very easily through these processors. So now I have to configure them. So I'm going to turn these on. So the readers I can just enable. The writer I can just enable. There are configuration options if you want to change some different things within your services. You can do that. Now the Elasticsearch client, that needs a little bit of work because I got to tell it where it is, right? So I'm running on localhost. I'm not securing it. So I can just do localhost 92,000 is my port. Click OK. I don't have any authorization on it. We'll make it real simple. And then, you know, if I want to set read timeouts, any of the kind of tuning things with inserting data or reading data out of my Elasticsearch, I can tune those here. I'm not going to worry about those things right now. Now it's switched to be just disabled. So now I can enable that one. And once I've enabled that, those three services that work with that processor, suddenly now I have a red box on it, which means it's configured properly, it's just not running, right? So if I were to start this, I've already got my relationships going, I can push this little play button here, and now it's running. But there's no data coming into it yet, right? So I need to call my invoke HTTP to get the CSV data that's going to be fed into Elasticsearch, parsed out, created as records, and then inserted into my search index. I can run this by just the same way as I did the record. But if I just want to run it once just to test something, I can right click here and just click run once. And what that's going to do is it's only going to make that get call once. Now there's state where it'll say, oh, did I call that URL already? So it doesn't constantly call the URLs until you clear out the state. There's ways to do that. But we're just testing things out. For the impatient, I can refresh. And then I can take a look and see what happened. So in here, I can see I had one task come out of that. And when it comes out, once it gets into NiFi, it becomes a file. And they call these things flow files in NiFi. So I go out with HTTP, I get the response is saved to a file, and the file is passed between the different processors to be operated on. So if I want to see what those files look like, I can right click and view data provenance. So everything that happens in NiFi gets recorded. So if you change a file, if you transform something, it actually stores the before and after, so you can audit what's happened to your data. This is really important, and it can be very important, especially if you're dealing with AI data, where there aren't a lot of things in the frameworks that are out there to tell you how AI may have changed it. It's like, oh no, it changed. Well, what did it? The model. Okay, well, what did the model do to it? NiFi can track those things. We're just working with HTTP right now. But if I click here, I can view the details. I can see, okay, we came out, we invoked HTTP. If I look at the attributes, attributes can also be attached to the flow files. And this is just metadata about the file, not the contents of the file, which is going to be CSV data, but attributes about it. So I can see different things like, okay, well, what was the request duration? Like how long did the HTTP request take? I can see that I got a 200 status code. Good, means I got my data. E tags, different things that are coming back as headers. So if I need to debug something, I can look at the attributes of my flow file and figure out if anything's gone wrong or if I'm getting the values that I expect. And then finally, I can look at the content. So if I want to take a view, here's my CSV content with all the salary data in CSV format. So this is what came out. All right. So that all also went to my Elasticsearch instance, right? So if I want to look at my Elasticsearch, I can also look at data provenance there, and I can see what happened. Now, there's a bunch of things in here because it took every single row and converted it into a record and then inserted those into my search engine. So I can look at the individual records that went in if I want to take a look at that. And if I view details and view here, you'll see, oh, it's in JSON format now. My record writer took the CSV record, turned it into JSON. So it did this conversion for me following the addition of it to OpenSearch. And then if I want to check OpenSearch, if I bring up a Postman collection, and again, my index is CSV index, and if I want to send that, I'll see now in JSON, I have all of my employees indexed in my OpenSearch database. It's 2 processors. Pretty simple. Didn't have to write a line of code. I'm able to take data, put it into another system, and now it's in a search engine. So that's pretty cool. This was kind of mind-blowing for somebody that has done Camel and a lot of the other frameworks out there to move data around where you're writing code to configure these things. I can just do it with the UI now using Apache Nifi. Any questions on that? That was a ton of information, and I'm going to keep repeating all of these other terms that I use throughout the presentation, but we're going to switch gears a little bit. So any questions on Nifi? Okay, you all are perfect experts in Nifi now, right?
Here's a question.
Yeah, question.
Here's a question from YouTube.
Okay, great.
Can Apache Nifi be a replacement of Azure's data factory for data processing, even on cloud platforms?
It's a good question. I don't know what Data Factory does. So I know some of the Azure products, but I'm not an expert in there. So I mean, it is good at transforming and pushing data around to different places. If that is what it does, potentially, but it depends on your use case. You know, this runs in the JVM. If you have a crew of people that are good at maintaining Java programs and you understand how to do that, running an Nifi instance within your corporate VPN may just make sense. You may want a SaaS offering instead. That's one of the things my company offers. But yeah, I can't speak to it because I don't know that product, unfortunately. So, and we're here at Microsoft. I shouldn't be talking poorly about any of their stuff anyways. All right, so yes, question. Yeah, so great question. So Apache Nifi, it can scale horizontally, meaning if I have a cluster of these Nifi instances, I can process a lot of data in parallel. Each one of these processors can be run multi-threaded. Also, if I want to increase how many of these files that I'm downloading at once, I may split it and partition it and have multiple threads pushing into Elasticsearch. So there's a number of different ways you can scale, but it also scales horizontally. So there is a Zookeeper instance that you can use in order to keep them sort of in sync. So it does scale up. And that is one of the powerful things that you see in a lot of Java programs. Because when I was looking at all this, I was actually not working for the company I was working for. I was a consultant. I was looking for a talk to do on how to tie together a bunch of different AI projects that seemed interesting to me. And I needed something to move the data between them. And you know, there's a lot of different things out there that are written in Python, that are written in other frameworks that can do things like this. But I'm a Java guy. I'm a Java champion. I love Java. And I know that I love Java because its ability to scale, the amount of libraries that Java has for running a distributed system, it's kind of unparalleled out of any other language out there. The JVM is amazing at doing this sort of thing. So knowing that, you know, hey, once I figure out how to use this framework, scaling it up is not necessarily that hard of a problem because I know the JVM can scale up. I know I can distribute it. You know, in the case of Nifi with Zookeeper, they keep everything kind of coordinated. And I can run it at a massive scale if necessary. And you know, that goes for a number of these things that Nifi integrates to. Like, you know, so Kafka and OpenSearch are things that scale to very, very high levels, right? So Nifi integrates to all of these other open source projects and a number of projects that are paid products as well. So there's a ton of different processors for integrating to things. And if you don't see what you want, it's open source. There's lots of examples out there that you can pull to write your own if you have a custom integration. But you can see what we can do with just out of the box stuff. So with all of the, am I still on? There we go. With all of these Java processors, are there certain things that I might not want to write in Java? And this is a hard thing for somebody that's a big Java developer and likes writing most of their code in Java. So one thing kind of happened over the last couple of years, and it didn't happen over the last couple of years, it's been going on for a while, is just kind of the growth of AI and how companies are using AI and what AI can do now is really what it is. When I got my master's probably about 20 years ago, and I took pretty much every AI course I could because it was very interesting to me, and I wanted to be able to use it to do cool things. The problem is 20 years ago, AI was like for parlor tricks and very simple use cases where you had a lot of boundaries on it, and it couldn't really do anything interesting. The fact is now, yeah, it's not perfect, far from perfect, but it can actually do interesting things on its own, where I don't necessarily have to babysit it or keep the parameters on it where I used to. So AI has become extremely interesting use case for businesses to be integrating to. So I was looking for a way to put a talk together of how I can integrate these things together. Now, the thing with AI is that it is a very academic heavy subject matter. Most of the people that are doing and practicing AI are still working at universities. If you're working with AI at work, chances are you're still reading journals and things like that and looking at GitHubs from people doing doctoral research and trying to figure out where these things fit. And one of the major languages that people are using for ML and have always been using for ML and AI and data science projects has been Python. Now, this survey is a little bit biased. This is from JetBrains, and it is a survey of Python developers of how often they use Python to do data science. So it's a little bit lopsided. If you ask Java developers, I expect this number would be a little bit lower. However, it does represent that there is a lot of usage going on in the Python community around data science. And that's clear by the number of libraries and things out there that are in the Python ecosystem that have very mature APIs on them, are very widely used, and have very vibrant open source communities. So when you look across some of these slides, there's a lot of these libraries that do not have equivalents in the Java community. So there are things that it can do. Yes, Java can do all these things, but the amount of work and the amount of maturity of the libraries, it's just not the same. What people are able to do in Python with some of these libraries is a little bit more difficult right now in Java. Doesn't mean Java won't catch up, but at this point in time, that's kind of where the industry is using a lot of these to either do numerical, so matrix multiplication, matrix operations, OpenCV, and a lot of these are actually written in C, but Python has some really great bindings for it. It has really developed APIs where it makes it easy to use the C code underneath it. Where yes, Java also has some of the bindings, but the APIs are a little bit different, sometimes a little bit clunky. So where does this kind of bring us? What I kind of think about that is, languages and libraries tend to evolve based on usage. So if you have a number of academics and people that are doing this research are using Python and evolving these libraries, it's obvious why Python has such mature communities around the data sciences is because the people that are doing the research and the people that are writing the papers are often using Python, and they're getting the pull requests and the commits to make those languages and those libraries more mature. So the Eric Raymond quote is, it's nice to have good ideas, but your users often have good ideas, and often their ideas are better because they're the ones actually experiencing the pain when things aren't working the way they're supposed to. Highly recommend growing at a language level. So that speaks to a lot of libraries, and Raymond was talking about Linux and a number of things in his book, The Cathedral and the Bazaar, when he made this quote. Growing a language by Guy Steele. So Guy Steele is a JVM architect from way back when Java came out. Did this talk, and this is when talks didn't have slides, they had just projectors. Did a talk about growing a language. It's hilarious, but it also kind of gets to the point. When you have users giving you input, the language evolves to meet the needs of those users, right? So a lot of what came out of Java in distributed systems and the things that we saw back in the early 2000s when Java was taking off, those were the big problems that were being solved. Java solves those problems very well. When data science and Python, data science and AI were starting to come up, a lot of the brain matter was in the Python community. So that's why those are kind of mature. So what this brings me to is we're not probably all researchers or anything like that. Most of us are just trying to make a buck coding for a living. How do we enable developers that are just that are working for companies to use the best tool for the job, right? So some of these tools are going to be Java tools. Some of these tools are going to be Python tools. So to bring this full circle to Nifi, what they've created in the Nifi 2x release is a Py4j plugin that works with Apache Nifi. This is a part of the 2.0 release, so it's not part of 1.0, so you have to use 2.0. And what I'm going to be talking about are specifically in the Milestone 4 release. So 2.0 is not yet fully cut, and I don't know when it's going to be cut. So if you want to ask, that's my answer up front. But it has a number of capabilities that allows us to tap in to some of these Python libraries and make it work with the JVM. So that's what I'm going to be talking about next. So before I get into that, let's talk a little bit about how Py4j works. There's a lot of different ways to do multi-language bindings. So within Java, one popular thing is Jython. So Jython is a library that allows you to run Python on the JVM. Similar to kind of how Rhino worked with JavaScript, Nashorn after that, and Graal worked. These are tools that allow you to run other languages in the JVM. As someone that has done this professionally with a lot of these different projects, the thing I have always found is that once you start bringing in libraries from the outside and bringing all those transitive dependencies and the complex language ecosystems that these have, something is going to break. Something is working natively. Something just doesn't jive well with what the language spec of the JVM is expecting. The language may be changed, and maybe it's using a future version of Python that they haven't gotten into Graal yet. So there's always limitations there. The thing about Py4j is it actually starts a Python process. So you're running a Python app alongside your Java app. So you're not running Python in the JVM, you're running a Python app that is able to communicate with your Java app. And that communication is happening over a socket. So again, if they're on the same server, local socket, you have a Python process, you have a Java process, they're talking to each other to keep the data in sync. So a little bit different approach than you'll see with other language bindings. Oops. All right. So this is not a Py4j thing, but this is a Nifi thing. So Nifi, when we're talking about those processors, all of the dependencies that go into processors in Nifi exist in their own class loader. So when you think about like a Tomcat server, or who remembers OSGI? I remember OSGI, I was a Felix committer, or I am a Felix committer. Those types of frameworks where everything's running in a class loader allows you to have dependencies that might have different versions, but are running in the same JVM. For example, if I have a Commons Lang 2.4, but I have a project that's running that needs 2.3 because of some compatibility issue, if I'm running in separate class loaders, I can have one running 2.4 and one running 2.3. That is from the ground up in Java that they designed the language to be able to do that. Python, if you run Python on your desktop and you install something just without doing anything else, it installs globally. It's like Node.js, right? It's like, oh, I just installed it, and now it's everywhere, right? So it's working on my laptop for every other program that I run, which is not always ideal. So what Python has and what Nifi is using to keep that isolation between your dependencies is a virtual environment. So when you use a virtual environment in Python, what it does is it installs all of the dependent bundles to a directory that is only used by that program. So the process that's running as a processor in Nifi with these Python environments, they are all separate virtual environments. So if I'm using PyTorch version 2.3 in one, and the other one I'm using PyTorch version 2.2, works just fine. They're separate processes. They have separate dependencies. They're all isolated. So they've been able to copy that ability from the JVM in the Python processors. And then finally, okay, well, how does the communication work? So, am I serializing everything about the object over and then serializing it back? Folks that have worked with language bindings that way, it's super expensive, gets super slow. What they use in Py4j is object proxies. So what you end up defining is an interface that allows the Python process to communicate back to the live Java objects that are running there. So when I make a call on an object that is on the heap in the JVM, there is a interface for me to update that. So if I have a byte array and I need to change what's in the byte array because I'm changing the structure of the data like I did in my other processor, I can write a new byte array that's going to serialize just the byte array back into a Java byte array, and then that gets put into the same object that's already on my heap. I'm not deserializing and reserializing every single time I change between processors. So it's sending these commands over the socket that are going to update the state of the objects. And when you have, if you don't have a ton of concurrency going on at the same time where there's contention for those objects, this works just fine. And in Nifi, that's the case. All right, so just a visual of what I'm explaining. So when the JVM process starts up, if I have a Python processor, it's going to initialize the virtual environment for that Python processor. The Python processor is going to have bindings to that Java object. It's going to execute, and then as it executes, and this line might keep going, right? There could be many interactions between it. It's going to update the object proxies back in the JVM. So when we transition out of the Python processor and back to the JVM, our object is what we expect it to be after the Python process is executed on it. Any questions on that? All right. So let's talk a little about integrating. So we talked about how it manages dependencies. There are 3 ways to do it in Nifi, depending on what packages you're going to use. There's a way to put it as a member field in the processor. I'm not even going to talk about that because that's probably the worst way to do it, is just integrating it into your code so that you're saying what your dependencies are. If you're a Python developer, you're probably familiar with requirements.txt files, where I'm going to just have a name of a package equals and the version number, or I might have a range or something in there. It also supports that with your project if you're a Python developer and that's how you want to do it. What it will do, though, in order to satisfy that, is it will spin up a pip process. So if it's not all local to your laptop, you're downloading stuff from the internet while your Nifi instance is running, and that while the process is staying up, it will delay the process of start until it gets all those dependencies. The other way is you can bundle what's called a nar file. So nar sounds a lot like jar, sounds a lot like war file. Doesn't sound like war file. It's almost spelled the same. It's the same exact file format. It's a zip format where it has the Python code inside and can also have the bundled dependencies. I'm going to talk about that process in depth because that's the one I think is the best way to be packaging these things all, because then you're just moving one file, which is a zip file with all your code in it. And you don't have to spin up a pip process or anything else. We'll get into how that works and some of the supporting tooling around that in a minute. All right, so what can I do with it? So we saw where we could download stuff off the internet, put it into a flow file, change things up with the flow file, and send it outbound to another program. So we did that in Nifi. The Python processors can't do everything that the Java processors can do, but they can do a lot. The first thing you can do is transform flow files. So where we saw data come in off of HTTP and go out as a file, it can do that. It can do manipulations on it. Like if I wanted to calculate, take somebody's annual salary and turn it into a monthly salary and then change the flow file for each person, I can do something like that. So I can transform the whole flow file as a whole as it comes down. So if I was going to do something in batch, I can do that in a transform flow file. I can also create things. So let's say I want to start a process with something that is an output of a Python program, but there's no input. So it's not coming from the internet or anywhere else. So I'm going to create the flow file in the Python processor for the starting point. So there's nothing pointing to that processor. It's just at the top, and then there's stuff coming out of it. I can do a create flow file transform to start that with. And then we also saw so the CSV, we've got a number of rows there, right? So those can all be broken into records. And I can take a single flow file that may have many rows and do specific operations on just each record. So I guess my example that I gave about getting salaries and converting them from annual to monthly, that would actually be a better candidate for transform records, because chances are I want to work on each record individually. So as so-and-so's salary comes in, I'm going to divide that by 12, change that as in the record format and send it outbound one at a time, instead of trying to do it to the entire CSV file where I have to parse and then do it in batch. So those are the three things that I can do. So let's try putting this all together to do something interesting with an AI use case. And we're here at Microsoft, so we're going to talk about table transformers, because this is a Microsoft model that is available on Hugging Face. And the purpose of this model is it takes an image of a table, or just an image in general, and it can detect if there is a table in it and give you the coordinates of that table. So if you wanted to clip it out to do further processing on it, you can. It will also detect structure of the table. So it will draw bounding boxes around rows and columns. So I'll have a bounding box coordinate that will say, hey, here's a row from this picture, here's a column, and I can calculate intersections and all sorts of things if I want to try to divide that table into a bunch of different smaller images as cells. So basically being able to break data down visually, and then if I want to send it to OCR or something like that to further process it, I'm able to do that. It has several different classes, again, rows, columns, column headers, projected columns. If there's, like a row that's actually just like a breaking point between two different tables, and a spanning cell, which is like if I take Excel and do a merge, where there's one cell that spans multiple columns. So it detects all of those things in the images. And it's available open source in Hugging Face, and also at the Microsoft GitHub. So how does this work? So how does this model work? So we're going to learn a little bit about AI to understand some of these neural network models to understand how this works. So it's going to take an image. When this is one of Apple's charts or tables from their 10K filing from last year. What it's going to do is it's going to take that image and it's going to turn it into a vector. So the first thing, it's going to look at each pixel and it's going to pull out information about where that pixel is located, the red, green, so the RGB values of that pixel, so it knows what color it is, and it's going to turn that into a vector. So this is a tensor vector from PyTorch that is taken when this image goes through and gets converted into basically a vector of floats that describe the pixels, the individual pixels that are in this image. Once it's encoded in a bunch of floats, now it can be fed into a neural network. So neural networks are it is a large network of functions where numbers go in, and they cause the neurons to fire, so an activation function to fire or not fire, depending on the weights in the model. And this happens across many, many layers. This model is, I think it's about 100 megs big, so it's not as big as like a ChatGPT or anything like that. But it has many, many weights and many, many networks to it. What comes out of there is logits and the prediction boxes. So the logits are essentially the classes that are detected. So a model can be trained to detect several different things. So we talked about those things. So so rows, columns, headers, those are all classes that the model is trained on. The logits are going to score each thing that it detects, and the thing that has the highest number is what that thing is. So if it sees something and says, yeah, this might be a row, but it really looks more like a column, the column is going to have the highest score. So it's going to say it's going to end up classifying this thing as a column based on how the weights go through. The other piece is the prediction boxes. The prediction boxes are going to say where it's at.
Now, these don't look like locations right now because it's not scaled to the image, but these are basically X, Y, Z coordinates of the bounding boxes that come out of the prediction box. So you have a bunch of vectors coming out of that. There's then a post process which normalizes the score, the logits into scores. So you can see what the different things that are detected are. And then you can also see the actual coordinates of the bounding boxes with the size of the image. These are now scaled to, so if I were to draw these XY coordinates on the image that I fed in here, I'm going to get those relative to the size of that image. So these are the three phases of how this model works. Now, if I were to try to convert that into a Nifi processor, what kind of interesting things can I do with it? Well, if I say I want to take that image, I want to process it and annotate it and draw on the image the bounding boxes that are detected, I can do that by running through the processor and then using OpenCV to draw rectangles of different colors to represent the different things that were detected. Write it over the image comes out of the flow file. The other thing I can do is I can just take the data that was extracted from that, the coordinates of the bounding boxes, what their labels are, and put it in a format called COCO. So COCO is a JSON-based format that is typically used to train these models, where if a user goes in and they draw a bounding box over things, COCO is the way you can store it to say, okay, a user drew a box that says this is a row or this is a column, and here are the coordinates of that. And I can use that to train my models, but I can also use it to vet the output of my AI model to make sure it's doing the right things. So I can also create a relationship in Nifi to do that. So I talked a little bit about the dependencies. So again, the model itself runs a PyTorch model. A lot of the post and pre-processing is done with NumPy. So working with vectors, and I'll show you a little bit of that. And then the image piece of drawing on the image and changing the image into a way that it can be worked with in the models is done with OpenCV. So let's look at some code. We've talked about that enough. All right, so if I go into my talk, I have my project here with my table detector. So this is something that's auto-generated using a program called Hatch, which can generate Python projects for me. We'll get into more of that later. Within this project, I have my table detection processor, which is here. And you'll see I'm importing a lot of those libraries that I talked with. So Python's similar Java, I'm going to import a bunch of stuff. So I need those in my project. So my project is also going to have this PyProject TOML that's where I'm going to define my dependencies. So here's where I've defined the version of NumPy that I need, the transformers. So this is Hugging Face transformers in order to download and run the post and pre-processing on the model, as well as the model inference calls. I'm using Torch, again, that's PyTorch, which is creating the tensors that are getting fed into the model. OpenCV we talked about. And then I also have this data classes.json, just useful. Python kind of stinks at data structures, so there's libraries that help with that. And TIM is another vision model library from Hugging Face. So I can define my dependencies just like I do a Java project in this file. So having those dependencies there, I can then use these imports. Here I'm using table detection as the name of my processor. I'm using a transform, so I'm going to take one flow file, which is the image, and turn it into something else, which is either going to be that COCO JSON format or another image with the annotations drawn on top. So now okay, good. Now we get to talk about a little bit more about Hatch. So my current employer has a open source plugin to help build NAR files for Nifi. One of the reasons you want to use the NAR plugin is because if you're running in production and you're trying to run pip in production, most people are not going to let that happen because you're going to close off the network to not allow you to download just any dependency straight off the internet and run it in a production environment. You want to be able to test your dependencies in a lower environment and package them in a way that I know I'm getting the same version each time and I know I'm getting code that's going to run. The Hatch plugin allows us to do that by downloading all the Python dependencies, putting them in the nar file in a directory where they can be unzipped at the time the plugin is installed with the same dependencies across environments. So if I take this nar file from dev and put it in prod, it's the same exact dependencies that were used in dev are being used in prod, and I don't have to wait for them to download. They're all in the nar packaging that gets exploded and then run from Nifi. So it'll format all of that so that it can just be dropped in the extensions directory. Because if you don't do this, you're moving each individual Python file over into the Python extensions directory along with what you're using to manage the dependencies. So this simplifies it very much. And yeah, while it's created from an employer, it's all open source. So there's no reason you can't use it. It's Apache licensed. You can just use it right out of the box. The other thing you have to decide is what the properties are. So we saw the properties in all of our processors, right? So the processors allow input. These models, there's actually 3 different table transformer models. One that's been trained on exclusively financial data. There's one that's been trained on, I think it's academic data. And then one that's just taken all of it together and trained it. This is going to take those properties. This allows me to change the model without writing any new code. So I can have a property for that. The other thing I can decide is whether I want annotated inputs of the image with everything drawn on it or Cocoa data. So if I go back to my code, what I end up here with is I define my relationship. So I have my Cocoa relationship. So this is where it's going to come out in JSON. This is where it's going to come out as an image. So I define those in my Python file. I'm going to define my property descriptors. So this is the name of the model that we saw. So this is going to contain a default value, which is the table recognition structure. This is all of them. And then another property with two allowable values, Cocoa and annotated, to say whether I'm getting the Cocoa data out or I'm getting the image out. So I initialize all of these up front. All right, so we talked a little about the relationships. The other piece is the lifecycle behavior. So unscheduled is when the processor starts. So when I push the play button, there's an event that fires called unscheduled. So within my code, what I'm doing on scheduled is I'm taking the name that I inputted into the box of the model, and then I'm using a table transformer for object detection. So this is a Hugging Face class that takes the name of the model, and what this will do is it'll download the model and set that model up for me to run methods on it, like inference, for example, to get out my bounding boxes. This feature extractor, this is another Hugging Face class. It's used to do the pre and post processing on the image to turn the inference information into stuff I can actually use. Unstopped, I'm not using. There's nothing I need to do to stop it except stop it. And then finally, where the meat of it is in this transform method. So this is where we're doing the things that I had in my other slide. So if I go down here to my transform method, I'm going to take in the flow file and the context. So off of the flow file, I can get the name attributes. I can get all those attributes that I was talking about, where if it's metadata, I can keep track of that. And then I can start by taking the flow file contents as a byte buffer. So this is coming across as Java, but then being converted into a Python byte buffer. I can use OpenCV to turn this into a NumPy array. So now I have an array that I can feed into my model. I've got a couple of just tuning parameters that are going to help resize the image to make sure it's the right size for the model, because these models have defined sizes of what they can work with as far as data. So this will make sure that my image is not too big. It's going to fit into the size of the image. I'm going to run inference using the encoded version. And that's going to give me the outputs. Now that's just that tensor, right? So it's the logits and it's the prediction boxes that aren't scaled yet. From there, I'm going to run the post process, which is going to align what came out of the model to the actual image that I had. So I have coordinates within that image. And then here, I'm just reading what I decided on for my property. Am I going to output Cocoa results? Or am I going to convert it and plot the results of it in an image where I can use OpenCV again to draw the rectangles of the actual, the things that I'm plotting. So all this code is in my GitHub. If you want to play around with it, it'll be available after the talk. So let's get through. Okay, good. Let's ship it. So for me to be able to run this, so I've got my Python all written. I'm going to use the hatch plugin to compile it into a NAR file. So I'm going to run this, and what that's going to do is it's going to download all the dependencies, and it's going to create a zip file off of that, that plugin. Here's my NiFi instance. If that's, hopefully that's readable. So if I'm going to stop it right now, because I'm going to install the version that I just built. Right, so I'm going to stop this while this is building over here. All right, we're still loading up the dependencies. From here, I'm going to first clear out my work directory just to make sure there's nothing left over from the last time I unpacked it. Okay, my build is done. I've got my NAR file here in the distribution directory. So from here, I can copy it into the extensions folder. So I have my zip file, it's going into my NiFi extensions folder. And now what I get to do is I can start NiFi back up. So now my plugin is installed as a Python plugin in NiFi. All right, so I'm going to go back out to my main flow files, and I've actually got this one already built. Now, what you'll see is when you've got your Python processor loading, as it's exploding the NAR file, you may see a little yellow box there while it's loading that up. If you get an error while it's loading up, you will also get a marker like that. Maybe your Python code is not running properly. You'll get some errors, so you may have to check the logs. If you're not using the Hatch plugin and it's downloading the internet from pip, you will also see that marker to let you know that it's waiting to download all the dependencies. But it looks like it's all done, so now it's running. So this flow basically just takes something off the file system from the table images directory. It's going to put it through the model, and right now I have it configured to create Cocoa results. And off the Cocoa relationship, it's going into a JSTL transform, and all I'm doing is I'm transforming it into the schema that I have for this specific version of OpenSearch, where I'm just taking the annotations, which is where the bounding boxes are found in the image, and I can index that along with the file name. So if I have a bunch of these, I can keep the annotations of where it found things in the image along with the file name to search for it later. And there's our put Elasticsearch record that's going to add it to the OpenSearch database. So from using this one, I'm going to bring that Apple 10K that we saw on the prior slide. I'm going to load it in there. We'll refresh. We can see it ran through. The model ran pretty quick. Let's take a look. So we had content come out. So this is the Cocoa data that was found, and it's finding, so the image annotations, so category IDs. If I were to load this piece into one of my tools for looking at Cocoa data, I would be able to see the overlay of the image. In fact, let's do that real quick. So if I were to change this processor to, instead of indexing it, stop that, delete that. We'll just move this. So it's going to put it on the file system. So I'll have a .json file. We'll add it there. Start it back up again. Let's move it over. Let's copy it again. Let's run it back through the model. Refresh, good. Let's get VIA up. So VIA is it's an open source browser-based tool for viewing Cocoa annotations. So if I load this, if I import Cocoa format, table out, my Apple chart. So now I can kind of see where it's detecting things. So I can see, hey, this was where the table column was drawn. If I want to look at where the row headers are, this is the row header. So if I scroll over here, I can see this was detected as a column header. So I can kind of see the work of the model. And if I wanted to get this out with the image drawn on, I could just change that property from Cocoa to annotations and then send that to the file system. And if I were to look in there, So here's the PNG version. This is it with the bounding boxes drawn over the image. So this is using OpenCV. So I can do a lot of different things with these AI processing models. I can use those coordinates to clip these cells and then send them to an OCR and then read what's in the cells. And then I can turn an image into a CSV file. So there's a lot of things I can do with this, starting with it being in NiFi and then starting with using some of these Python processes to tap into the AI ecosystem that's out there. All right, so let's talk about the things we didn't get to talk about. So this, what I demoed is just a quick way to get started. And again, you can kind of show the value of being able to bring these things in to existing data flows that you have and that where you're moving around data and you're able to show, hey, we can lop on some of these models and some of these AI processes very easy to our Java ecosystem. One of the things I didn't talk about is, well, okay, we're running these Python processes along with our NiFi instance. These Python processors have dependencies like PyTorch, which if you look at the dependency tree is huge, right? There's a ton of other libraries that go into that, and those libraries sometimes have security vulnerabilities. And if they have security vulnerabilities, they don't just impact the Python process, they can also cause problems for the server that's running the Java process. So having those things coupled together, there may be things I need to do in the Python processes to tighten those up to make those more secure. The other one is GPU acceleration. This model runs pretty fast without GPUs. There are a lot of models that run really slow on CPUs until you add a GPU, and then they're hundreds of times faster. NiFi is very I/O intensive and can be CPU intensive, but NiFi generally doesn't need GPUs, but these models do. So you may have a disconnect between the hardware that you need to run the AI processes and the hardware that is running NiFi. And you may not want to spend on GPUs just to run NiFi if that's what you're going to be doing most of the time. So you may want separation in that. The other piece is scaling. Again, the Python process itself is not going to scale like the NiFi will. I mean, if I have multiple NiFi clusters, might have multiple Python clusters going. But learning to tune and scale these things out, it takes a little bit of practice. It is not necessarily an easy thing. Just putting it on NiFi is not going to solve all the scaling problems you have. So this is where I get to do the pitch. If you're looking to run in production, we've been doing this for several months at the company I'm working for at Datavolo. So if you are getting past POC, you may want to talk to us about some of the things we've learned about being able to decouple these things and run them performantly once you're able to show value. The philosophy of the company, we're trying to enable the 10x data engineer. So it's not replacing data engineers with AI, it's making the data engineers that are already out there more productive. So that's what we're trying to do, and NiFi allows you to do that very well. So with that, I hope you guys have learned a little bit about NiFi, a little bit about Python for a Java user group meeting. I know I certainly have in the last few months, just trying to get up to speed on AI and figure out its place in the Java ecosystem. So if you have any questions, I'm available through email, through Twitter. As Mary said, I'm very active in the Apache community. So if you have questions about NiFi, I do work with a lot of the committers there. So probably have an answer somewhere along the line, or any of the other Apache products that I work on. Thank you very much.
Thank you, Bob. Yeah.
Any questions? Yes.
What's your?
Maybe we should have it.
I mean, I think it is really useful right now. So the question is, what is my vision for AI? Is it going to become real useful? I think it is useful right now in specific. It's not going to start replacing people for jobs. It's not. I think that part of it is overhyped. But it does have the ability to make the users better and the developers better. Like there's a lot of folks that I work with right now that use Microsoft Copilot to help them write code. They know that every time they use it, it may not be perfect. They're going to have to edit it, but it saves them some keystrokes. So they'll use it in certain places when it's like a really quick thing. Like if I'm building an entity in Hibernate, that's something that's been done repeatable enough that I may trust AI to take the first stab at that. If I'm writing an algorithm that nobody else has ever heard of and I'm going to have an AI do that for me, Yeah, I'm probably going to spend more time debugging the AI than I am going to benefit from it writing it for me initially. So there's cases where it's very successful and there's cases where it's not. The good thing is a lot of the places where it is successful is stuff that you don't want to be doing, stuff we're doing code gen for right now, right? So it's it can make you more productive in those spots. But yeah, are we at the point where it's like, hey, I can fire my development team and just hire AI to write my code? Yeah, I don't see that coming anytime soon.
So my job is safe.
I think your job's safe. Yeah. Any more questions?
Actually, we have one from the live stream.
Sure.
Stan Atuvi was asking, can NiFi cluster be installed on Kubernetes cluster and scale there compared to installation on pure metal servers?
Yes. So that's exactly how Datavola does it in our SaaS offering. So
Okay.
we put NiFi on Kubernetes so that so the runtimes can scale up to meet the demand of the data ingest and the processing that's happening.
Oh.
You know, some of the other things that we do there is, you know, we're talking about security, we're talking about the ability to work with GPUs. You know, we also have some microservice architecture around some of our AI microservices that allow the AI to scale up and utilize GPUs when they're necessary. And then, you know, if we're doing CPU stuff, the runtimes are running on efficient hardware. So again, just having time to work with the software and having people like a lot of the original developers on the team, like they know how to kind of do that deployment. But yes, deploying it on Kubernetes is absolutely a way to do NiFi.
Oh, nice. Okay.
All right. Well, thank you guys. If you have any other questions, I'll be hanging around for a little while. And then Mary, I don't know if there's anything afterwards, if you want to chat to that.
Yes. So in fact, we're going to do a raffle of the JetBrains licenses. I know I so far got 4, but I think I also announced it on the live stream. So yeah, so if, Che, if you can leave this on, because there are some participants on the live stream that are participating. I think we have 2 more. So yeah, so let me, I'm just going to plug this in to run that.
Yeah, that's fine.
That wheel, that wheel of thing.
I'll just move this out of your way.
Okay, yeah, no problem. Let me
And
see.
I think this is the one you want.
Okay, thank you. Yeah, okay. Let me quickly this first. Oh. Where's my wheel? Okay. Let's stand then the cloud. Okay. Let's see. Is it wait, is it showing? Do I need
Not
to-
yet.
Oh, so it just takes a little bit of
Yeah, you're good now.
yeah. Okay. Okay. So yes, or did you win something like in the past 9 months? Just want to make sure you didn't, right? Okay. Yeah, I know actually we do keep track too. So let me real quickly. JetBrains. We keep track of all the folks. So this will be Thomas. Okay, cool. I guess Thomas, you did it last August, so you're good. Yeah, you're eligible. Yeah, if you won something within the past 9 months, then you're not eligible. But you won it a year ago, so that's okay. Okay. So Thomas, so I'll enter one more. So folks, yeah. So Thomas, okay. Okay, so we have. Let me just make sure we have Maria and Igor. Oh yeah, okay, let me show that to you first. Let me get back to the, actually, let me get that, yeah. So you want to go to this, click on this form or scan the QR code, yeah. So for those of you on the live stream too, if you haven't already entered and would like to enter into this drawing, please visit this form. You just need to enter your name and your email address, so. good. So, all right. So the two of you, you all got in, right? Okay. Let me go to that the wheel. Where's my wheel? Hold on a sec. Too many things. Okay. So, did we have anybody? Do you mind checking on the live stream too? Nobody says so. Okay. I think we have Stan and Mikhail from the live stream. So yeah. And then we have two more folks, right? Yeah, I'll just type in your name, but although make sure you enter the form too. Yeah. Okay. Can you? Aman? Aman. AMM. Okay. And then you? Suprito. Suprito. Okay. All right. Okay. So we have Maria and then Igor, Neha, Tuan, Mikhail, and Stan, Thomas, and Aman, and Suprito. Anybody else wants to be on the raffle, but their name isn't there yet? All good? All good. Okay, I'm gonna spin twice. So we have 2 free licenses. Let me make sure. All good? All good. Okay, I'm gonna spin twice. Oh, so sorry. We have 2 free licenses. Sorry, sir. Thomas. Okay. All right. Congrats. All good. Oh, good. Okay. Right. I'm gonna spin twice. Oh, okay. So, wait. I guess because I. Sorry, sir. Hold on. Okay. All right. Sorry. Let me. I think because I have the other thing on. Wait. I guess because. Let me kind of. Sorry. Okay. One more. Okay. We have Stan. Stan is on the live stream. So, okay. So congrats to Stan. Okay. All right. Cool. All right. Well, thank you very much. And you have more chances if you keep joining us. Every month we'll have 2 free licenses for raffling off. So, and we may get more. And then plus, if you haven't already entered the new 4J raffle, let me go there too. Let me go back there and show it to you. The new 4J, so we have more chance of winning things too. Let me see where this is. I think it might be in the next one. Okay, so this is the one if you want to enter into the new 4J. Either they will be having another drone or something, yeah, something else. But they are doing it once a month for all of the users group. So yeah, so please feel free to enter that too. Okay, and then with that, this comes to an end of today's meetup, but we are still here for a little bit if you want to hang out and chat and all that. And also be sure to thank David too, who's sitting out there. Unfortunately, he's not feeling good, so he's not in this room, but to just say thank you to him. So thank you to Microsoft again for helping us. So, and thank you to all the helpers. We have Jay helping us with the video, John, who is here too, and then Nick too, also helping with the pizza and all this stuff. And then of course, Bob for his great presentation. So thank you very much. And thank you to all of you for spending your time with us. Thank you. So